myself. My name is Andy Brown. My official title is Warning Coordination Meteorologist. I'm one of the managers at the National Weather Service Forecast Office in Spokane. And that title allows me to do a lot of the outreach and education for this office. There's 122 forecast offices around the country. So this office in Spokane, our area of responsibility is the inland Northwest. We have, I'll kind of show that here on a map. We are responsible for everything that you see in purple, kind of north, central, and eastern Washington. And then our neighbors to the south are Pendleton Forecast Office, Seattle to the west, and then Portland down in that corner. So this is the state of Washington, but if you zoom out to the Pacific Northwest, I'm realizing that some of this is cut off just a little bit, but Seattle's to our west, and you kind of see the Pendleton forecast area in north central Oregon and south central Washington. And then we also have North Idaho as our area of responsibility. So that's how the Weather Service is laid out in the Pacific Northwest. And all these names that you see here, they are my colleagues. They have the same position that I do at these various forecast offices around the inland north or around the Pacific Northwest. These are all the warning coordination meteorologists. If you were to come out to a Weather Service forecast office, most of them are staffed very similarly. This is how it's all laid out. At the top is the MIC, or the meteorologist in charge. There are three managers under him: the science officer, my position, which is the warning coordination meteorologist. And then on the right side, excuse me, I just had dinner, so I'm burping, I'm sorry. On the right side there is the electronics technician, supervisor. And so we do have a couple of electronic technicians that keep everything up and running. But here in the middle, you'll see how many forecasters we have that work at our office. Most of them, as I indicated with this blue color, have more than 10 years experience here at Spokane. And then we have several that are newer in that 1 to 3 year experience in Spokane, and a couple of new meteorologists that have just arrived in the last year. And of course, we have the admin staff here in the middle. But it takes a lot of forecasters that work at the Weather Service forecast office in Spokane, because we are 24/7 and 365. So every minute of the day, every hour, every day of the month and year, somebody is at that forecast office watching the weather and working on the forecast for the next 7 days. And why we are doing that is because we are trying to provide a service not to just the public, but to our partners in emergency management, the media, utilities, school districts, health districts, all the core partners, transportation, all these core partners that we work very closely with. And the idea here, this is from an essay that was done back in the 90s that talked about why the forecast is important. And what the statement is that forecasts actually possess no intrinsic value. They acquire that value through their ability to influence the decisions of the people that are using that forecast. And so I share that a lot because it really puts into perspective about why the Weather Service is here, is that anybody can give you the weather. You can get weather from an app or go to the TV and see what's happening. The National Weather Service, we are providing that service, and we are trying to influence people's decisions by letting them know what to expect. So that is kind of getting to the nuts and bolts of why the Weather Service is here and what our mission is to save lives and property. And we do that through that ability to influence the decisions that people are making to save lives and property. So this part is not Chad Schaefer. He's not going to do this. I am actually. This part of the presentation was from a workshop that we did earlier this year, or actually late last year. And so what I did in this workshop is I kind of went over some of the latest tools that we have that are available. And it's always eye-opening. I think people are looking for more information and how do I find out what the forecast is and how do I get this information, it's all at your fingertips. It's right there. You just don't know how to find it. So these are some of the new resources that we have. Our website is weather.gov/Spokane. But one of the things that our science officer did was create this web page that is our watch warning advisory definitions. And it's really creative how he built this page, but it basically shows every watch warning advisory that we have. What is that starting baseline criteria for if you see a winter storm warning, what does that mean? How much snow should I expect if we were going to get a winter storm warning? So it was really creative way of showing what our criteria is around the inland Northwest. So this website's available here. And what I did on the website was I clicked under local programs and then watches, warnings, advisory definitions. And you can click on all of these different definitions for both cold weather and warm weather products, and it will show you what that criteria is. And why that's important and why I wanted to share that is because we've made some changes to our winter storm warning criteria. This was a national effort that all of the Weather Service offices around the country wanted to reevaluate what our starting criteria is and if we're doing a good job of letting folks know about winter storm conditions. And so this is kind of the color code that shows the inches of snow when we will start looking at a winter storm warning. The reason behind it here is we're trying to improve our regional and national collaboration. It's more aligned with our local climatology. And what we're doing this winter is we're evaluating this new winter criteria to see if it's really effective and if we need to change it even more. And so this is kind of zoomed in what that looks like for the Northwest. Most of the area now in the inland Northwest is 6 inches for a winter storm. And if we are going to exceed that 6 inch of snow, then you will see a winter storm warning. And I think so far we've only had 2 this winter. The big one was back in late November. On November 30th is when we had a pretty significant winter storm. But if you go up in the mountains, the winter storm warning criteria is 12 inches for a storm. And then if you get down into the lower Columbia Basin, it's actually 4 inches. And if you see this lighter blue color around Portland and along the Columbia River, that's actually 3 inches. So they only need 3 inches of snow to trigger a winter storm warning. So this is a new criteria that we're experimenting with, and that's what we're basing our forecast off of. So something else that is in development, this is something that the Seattle Forecast Office has developed. It's called a SAFER dashboard, Weather Hazard Situational Awareness for Emergency Response. It's a dashboard that has all the tools in one location. It's GIS based and it's very powerful. You can put a lot of different things in here. I think these became very popular with COVID. A lot of folks were developing these COVID dashboards. And so some of the forecasters in the Weather Service were like, hey, I could do that for weather. And so they were very creative and came up with a dashboard. And so I asked during our workshop, is this something that our partners would like to see? And the overwhelming response was yes. They want us to develop this for the inland Northwest. So this is in development. I just wanted to share that at some point. This is going to be public facing and just another resource for everybody. It doesn't have to be our partners. It can be anybody can have access to this and use this dashboard to kind of keep track of weather conditions and the various hazards that we face. So that's coming soon. Something else that's really cool that we did recently was we're trying to symbolize, that's not a word. We're trying to socialize a new way of how we convey messages. Simplify is the word I was looking for. We used to have 3 different ways to relay hazardous weather. We had the Outlook, HWO, we had the Nowcast, and we had this Flood Potential Outlook, or the ESF. And so we have combined all of those into one new product called the SPS, or the Special Weather Statement. And the reason for that, besides the simplification, is to increase the visibility. We're going to see a lot more folks that will have access to this. And what I've noted is I have one of those Google Alexa at my house, or that's Amazon actually. I have a Alexa at my house. And when our office issues an SPS for severe weather or for dense fog or whatever that is, it actually alerts me on my Alexa at my house, which I think is really neat. So it's just a way of helping spread the word when there's hazardous weather. So that's just something really cool that we're doing recently, is to change it to the special weather statement. Another really great tool, and I encourage everybody to flip through this web page. On our main web page, weather.gov/OTX/winter, and you will have access to tons of probabilistic information. And what probabilistic means is the difference, or the opposite of probabilistic, is deterministic. Deterministic is we are going to get 2.6 inches of snow. That is a deterministic forecast. It's one single number. Everybody should know that the Weather Service and weather prediction is not that good. There is a range of possibilities. And so this probabilistic way of looking at weather information will let you know the confidence about how much snow or rain or wind we are going to receive. So here's a few examples of, this is the percent on the top, on the right side, the percent chance of at least 1/10 of an inch of snow or more. But it also breaks it down into the expected snowfall, the high end, and the low end. How much could we get, or what's the absolute minimum we will get at least this much? And so another example of this that we used back in early November was this probability of at least 2 inches of snow. And for the Spokane area, it was looking at about 57% chance of 2 inches. And then if you look at the probability of 4 inches, you could see that it was very unlikely, 0% chance of 4 inches of snow. So that could help give you that confidence of, oh, we should see about 2 inches of snow. It's very unlikely that we would see more than 2 inches. But what's really cool about this webpage is it goes from 1/10 of an inch, 1, 2, 4, 6, 8, 12 inches. So you can see at every level what's the probability. And so as we get closer and closer to a certain event, you can actually see how those trends will change, and that will give you an idea, some confidence in what that forecast is. So this is a really powerful tool, something that we're trying to socialize and make sure everybody's aware of to help make those decisions. This is another really cool tool, and I'm going to send this, I will send this slideshow, and so you can see this. So don't feel like you have to write down all these web links. I realize that these links are really long and convoluted. But this is another very powerful tool. It's a threat matrix where you can build a matrix for the criteria that you want that means something to you. You don't care about humidity, or you don't care about wind chill, but I do care about wind speed and how much snow we're going to get. So you can build a personalized matrix on your location and have a link for this, so you can just very quickly look at this and see what the snow, what's the possibility of all those things. So it's just a really neat tool. My email address is right there if you have any questions, but I will send this link out and you can play around with it, customize it, and it's just something else that you can use. Another new tool that we keep on refining is this graphical hazardous weather outlook. For all these different weather hazards, this is kind of a one-stop shop to very quickly look at all these little chiclets, I think they're called chiclets, and see, oh, orange for fog. Okay, I don't care about fog, but maybe I care about snow. I can see some heavy snow on Tuesday, a little bit of light snow Wednesday, Thursday, and then, whoa, Friday, Saturday, Sunday, heavy snow. So you can get a very quick look at the potential impact from all these different weather hazards. So it can be a very powerful tool. Another quick and dirty, just look at this whole matrix real fast and get an idea of what kind of weather you can expect. So I mentioned watches, warnings, and advisories earlier. And so I just want to make sure that everybody understands what the difference between those is, because I know that gets lost a lot of times. Is, we have an advisory, or we have a watch out, and then we upgrade to an advisory. Well, is that worse? I don't know. Now we have a warning. Well, what the heck is a warning? So I understand that can be very confusing. This is one way to look at it. And I'll start with watch. A watch means the conditions are favorable, but not yet occurring. That means we're 24 hours out or 48 hours out ahead of a storm. We see the potential for a significant weather storm, and that's when we're going to issue a watch. During the summer months, the Storm Prediction Center will issue a severe thunderstorm watch, and that's for conditions are favorable for strong thunderstorms, but nothing is happening yet. Once we have an imminent threat where the weather is occurring or it's imminent, we will upgrade to a warning. And that's when we expect hazardous weather conditions to happen if we issue a warning. If it's kind of an inconvenience or a minor impact, that's when we issue an advisory. So that's the difference between a warning and an advisory. A warning is a significant impact. Hazard is occurring, imminent, or very likely, and you should take action now. An advisory is more of a nuisance. The threat of a significant inconvenience is the way that this puts that, and to use caution. So there's your difference. These are kind of our legacy products that we've been issuing for years and years and years, as long as the Weather Service has been around, and we continue to do that, but it still gets a lot of confusion between what's the difference between watch, warning, and advisory. So sorry about the dog barking. Obviously, I am at home. One of the things that we have tried to do to help improve the understanding of what that impact is going to be. And this came from the November windstorm from 2015, November 17th, 2015, our big windstorm. Afterwards, I was talking to an emergency manager, and she told me, Andy, I wish you would have reached through that telephone and slapped me in the face and said, no, Andy, pay attention to this one. This is the bad one. And it got me thinking, like, how can I differentiate between significant storms and like extreme events? And so back then, some of the offices had been playing around with this idea of using a matrix or this 5-tiered color scale to differentiate between a minor impact and an extreme impact. And so the Weather Service has really invested a lot in the social science of this, trying to understand how people will understand this, and will this improve people's response if we can use color codes to try to do that. So this is something that we've adopted here locally. And you can see on this matrix, it's based on the probability, the likelihood of something happening, and what that expected impact is going to be. And so the granddaddy of them all is that high impact, high probability event is going to be that purple or magenta, an extreme event. And then you can go down from there. So you can have something that's very high probability, but moderate impact, and we'll end up with an orange. But this is one of the ways that we're trying to help differentiate between the low probability impact events or the high probability high impact events. And so one of the ways that we've done that is to associate wind speeds with impact. And so through feedback with Avista and other utility companies, we've discovered that these wind gusts that are in that 40 to 50 mile per hour range can have minor impacts, isolated to scattered power outages, and those are the types of impacts. Once we get into that 50 to 60 mile per hour range, we see more moderate impacts, numerous power outages, and then 60 mile per hour gust or more, that's when we see the high impacts and widespread power outages. And so we've actually sat down with the utility companies, and they've helped us come up with this wording and this color scale to make sure that we're all using the same language. Because we want folks to understand that when we're talking about wind gusts of 60 miles per hour, they're like, well, what the heck does that mean? So we want to put that into perspective about what you can expect with certain wind speeds. So one of the ways that we've done that is then we can use those color color scales and put them on a map. And so you live in Moses Lake and we have a windstorm that's coming. You look at this map and say, oh, I'm in the green, no big deal. But if you live over in the mountains, oh, I should really pay attention to this. In North Idaho, you should pay attention to this. That's where some moderate impacts are possible. So we've been using this map to help differentiate not just what the impact is going to be, but where the impact is going to be. It's very similar to that graphical HWO, hazardous weather outlook. And so what I did for this, and I've done this for our last several workshops, is I actually broke down when we assign a color to a certain day, to a certain event, I actually broke down how often we use each color and what's the typical weather that we'll see for those different impact levels. So for green, fair weather, common weather events, it actually comes down to about 63% of the time we're using that for very fair or common weather events during the entire year. Minor impacts are used for weather events that happen frequently. This is more for people's awareness. Local impacts are still possible. We could still, a 1/10 of an inch of snow could actually still cause problems. Dense fog could actually cause problems. They're minor, they're common events, but you should be aware of them. And so I have the examples of typical minor impacts, and you can also see that that's about 25% of the time we'll use that. So 63% of the time, green, 25% yellow, orange. I think you see the trend here. Now we're at 13% of the time, we'll use moderate impacts. Impacts to commerce are possible, and maybe proactive measures and or emergency response may be necessary. So I have all these different examples of what a moderate impact event is. Locally heavy snow, blowing dust, reducing visibility, flooding, cold snaps or heat waves. Then we get into the major impacts. These are rare or infrequent weather events. Only 2% of the time we are using this red or major impact level. And these are high confidence events that impacts to commerce are likely: widespread wind damage, heavy snow, severe thunderstorms, major flooding, all those types of things that can be associated with major impacts. And then the granddaddy of them all, less than 1% of the time, are the extreme impacts. These are exceptionally rare weather events. And you'll see all these qualifiers that I have for the examples: widespread heavy snow, extreme widespread fire danger, extensive record flooding, extreme and long-lasting heat or cold. So these are very rare events. We have used this magenta only a handful of times in the last 10 years or the 5 years since we adopted this. But that's because we don't get them that often, thank goodness. But these are high confidence that significant and widespread impacts will occur. So that's how we use the color scale to help you know what to expect, help our partners know just how bad it could be. So I'll take a moment here. I'm not sure how long I've been talking, probably too long already, 25 minutes or so. Let me check in. Oh, good, everybody's still there. Do you have any questions for me at this time?
It's not a question, but it's something the Weather Service tends to use color codes for different things. 8% of the men in America are colorblind.
Yes.
So they're worthless to me. I'm colorblind.
So that is one of the things that we have. It was really interesting. We used to have a different color scheme that was not friendly to color, is it color blindness? So we actually, the people that developed this color scale, and I think it's been modified and we're going to be changing it, tweaking it just a little bit more. They created this so that when it's printed out, there's like this natural gradation of light gray to dark gray. So you can hopefully the idea is that we have been very thoughtful in the colors that we used so that you can actually see the gradation in colors from light to dark, even if you are colorblind. And so these examples that I gave you, these green, yellow, orange, red, those are not the colors that I should have been using for this example. These new colors are the ones that I should have used for that as well, to try to highlight that we have put some thought into it because that has come up before, that a significant portion of the population is colorblind and could not tell the difference. So yes, we are aware of that and we are trying to take that into consideration. Is there anything else before I go into the next part of my talk? Trying to check in with you. Okay, not hearing anything. So the next part was just to talk about the weather. What's going on right now? Where have we been? And what should we expect for the last part of the winter? So hopefully you heard this winter, we were in a La Nina pattern. And a La Nina pattern is significant because La Nina patterns typically bring the Northwest increased moisture and more likely to experience cold Arctic outbreaks. And my goodness, November and December were perfect examples of that, where we had plenty of cold weather and lots of snow. And what's happened, I don't know if you've been aware of this, but this pattern has shifted a little bit to the south. And California has been under the gun since December 27th. I think it was just after Christmas that atmospheric river after atmospheric river, the jet stream is pointed right into California. So it's interesting in this map, Northern California is right on that edge of where they typically will be wetter. And then by the time you get to Southern California, it tends to be drier. And that transition right there can vary year by year and La Nina to La Nina. But this winter, they have been getting hammered, especially in the Sacramento, San Francisco, up to Reno and Lake Tahoe. They have been just getting hammered with storm after storm after storm. So much so that those local offices have asked for help. And so we actually sent a couple of forecasters down to Monterey, California to help out. They're doing 17 briefings a day. It's been incredible, the workload that they've had down there. So that's a little bit of a derail there, but it's just interesting to see how this pattern has shaped up over the winter so far. We have definitely experienced a wetter and colder winter so far, but that pattern has kind of been changing a little bit. So if we look back in October, what the Climate Prediction Center was saying was we have a 91% chance of La Nina conditions to persist through November. That reduces to a 75% chance once we get to February. And then by the end of the spring, getting into that February through April timeframe, it's just a 54% chance that we'll see La Nina conditions. And I should have mentioned this, La Nina conditions, all that means is the sea surface temperatures in this area that's circled in the bottom left of the Pacific equatorial region, the sea surface temperatures are below normal for a La Nina winter or conditions. If it's above normal, if the sea surface temperatures are above normal, that's when we have a El Nino. And so on the bottom right side, you could actually see over the last 12 years, have we been El Nino, neutral, which means temperatures are near normal, or La Nina, temperatures are below normal. And so you can kind of see it just goes back and forth. There's an ebb and flow to it. We'll have La Nina winters, we'll go neutral for a while, El Nino, back to La Nina, and just back and forth. But the last two winters, and now this is the third winter in a row that we are seeing La Nina conditions for 3 winters in a row. And that's only happened 2 other times since they've kept track. In the 70 years that they've been tracking this, this will be the 3rd time that we'll have back to back to back La Nina winters. So in the short term, that this trend of above normal precipitation and very active weather in California is finally going to transition elsewhere. So they are finally expecting some breaks. later this month. This is the January 18th through 22nd precipitation outlook and temperature outlook. So we in the Northwest are expected to get a little bit more precipitation, but temperatures should be pretty close to normal during that time frame from January 18th to the 22nd. The long range forecast, this is the 3-month average of January, February, and March, is very consistent with what we would expect for a La Nina winter. And they only update this forecast once a month. So this forecast was issued back in December, and they'll be updating this forecast here in another week or so. But what I would expect is the same. For this 3-month period, we are expecting above average precipitation and below average temperatures during that 3-month time frame. And if we look a little bit more into the future, February through April, it kind of is the same thing. The above average signal continues, especially in North Idaho and Western Montana. So above average precipitation, but for the entire Northwest, there's a pretty good signal for below average temperatures all the way through April. Does that mean that we're going to be cold and wet every day? Of course not. But what it does mean is if we look back over that 3-month period, over the entire winter, what we should see is that temperatures were below normal and that we were very active and had more precipitation during that time frame. So I talked about the differences between El Nino, La Nina, and neutral. One of our brilliant forecasters, what he did was he broke down. He went back and he looked at every La Nina winter, every El Nino winter, and every neutral winter, and compared to see if we could see a trend in snowfall and precipitation. And what he found was that all these sites for the inland Northwest, it averages about 110 to 140% of snowfall during a La Nina winter. So that means if an average winter, we get so much snow. For Spokane during a La Nina winter, we average about 123% snowfall during a La Nina winter. And what does that look like exactly? Average snowfall is about 48 inches for Spokane. During an El Nino winter, it's only about 35 inches. For a La Nina winter, it's almost 60 inches. And amazingly, neutral winters are actually pretty close to normal, to our average. So where are we now? So that's the next big question. If we go back to October 1st and we plot our snowfall up against the brown line, which is the average snowfall, this green line is the observed snowfall. How much snow have we received so far? And you can see we were very active November all the way up until late December. And then it's been pretty quiet since then. But if you add all of that up, we're sitting at 35.8 inches of snow so far this winter. And I added it up real fast. I look back at the records. That is the 19th snowiest winter through January 12th. So there have only been 18 winters that have been more snowy than this one so far. And I think if I asked this group, what was the snowiest winter on record, you would all say in unison 2008, 2009. So I grabbed that, and this is what that looks like compared to this winter, which is just amazing how much snow fell 2008, 2009. So yeah, this green line here is this year. That's our 35.8 inches. And this magenta line is 80 inches. That's what happened back in 2008 and 2009. And it wasn't done. I mean, we're just in January, so we got a long way to go. So kind of like what I was saying, the bottom line here is that these climate predictions can have skill in predicting seasonal totals and averages, but most impacts are associated with these short duration storm events, these windstorms or heavy snow events or flooding. So that's where you can stay in touch with the Weather Service, follow what we're sending out there so that you know when hazardous weather is expected. So the last thing I wanted to talk about real fast with is our weather spotter training. How can you get involved? And so this was something that we did back in November. We had several training opportunities. We had 4 different virtual classes that we offered back in November, and we'll do this again in the springtime. But I just kind of wanted to share with you that we are very active, and we are always looking for new weather spotters to help us out and how to measure snowfall, how to report hail or thunderstorms or flooding, all those things that we're looking to find out. I didn't mean to do that. So the web page here, if you go to our weather spotter resource page, it has all of this great information on how to become a weather spotter. And that includes, I think I should be able to go to this. Let me see if I can't. Weather.gov/Spokane. And if you go to local programs and spotter program right there, it will take you to the spotter resource page. And it has all these different ways to sign up and get involved. And the other one I wanted to point out was CocoRaws. CocoRaws is the Community Collaborative Rain, Hail, and Snow Network. And this is how you can help. You can see how many people around the country are making daily measurements of rain, hail, and snow. So all that's required here is once a day at 7 a.m., 8 a.m., you go outside and you take a measurement, and then you put it on this webpage. And you can join the thousands of people that do this every day. And you can see actually just how much rain and snow is happening in the last 24 hours up in Northern California. But this really helps expand our network and lets us know exactly how much rain or snow has fallen, and that will help improve our forecast. And so it's a great way of getting involved. All the resources that you need are right here, how to join CocoRaws. It will take you through the sign up process. What you need, the one thing that you need is a 4-inch rain gauge. And this is how you get it. You can click on that link right there, and it'll take you to the web page to get that 4-inch rain gauge. And then you select the time of what time you're going to report every day. And that will actually come directly to us every morning. We get an awesome report once a day with all of the different CocoRaws observers. So that's a great way to get involved. And I think that is all I had. Let me go back to this real fast. Here is our information again, our email addresses. The Weather Spokane office is nws.spokane. My email is over here on the right side, andrew.brown@noaa.gov. If for any reason you want to let my boss know that I did a horrible job tonight, Ron Miller is my boss, and feel free to reach out to him for any questions or comments. Chad Schaefer is our science officer. He's one of the guys that's down in California helping out right now. And Robin, she does a lot of the outreach with me. She is our hydrologist. So she does a lot of the flooding surveys and flood forecast. So she is another very important part of our team. So that's our contact information. I will save this and share it with the group so you have all these links nice and handy. And I will stand by for any questions. Any other questions for me?
I have a question for you, Andy.
Sure.
On the CocoRaws stuff, I noticed that there's like 6 o'clock and 8 o'clock, but I mean, that's, you pick your time that you're going to report, but I mean, that really doesn't take into consideration, you know, rain that happens at noon or 2 in the afternoon or that kind of thing.
So it is they created it so it was just once a day, and it's basically a 24-hour measurement. So you have that rain gauge sitting outside, and at 7 a.m. you go outside and you say, okay, it's rained 0.25 in the last 24 hours. So it's just a once a day, 24-hour observation that you're sharing with us. So as long as you're doing it at the same time every day, we'll be able to compare that over an extended period of time. If you're doing it at different times, one day you do it at 6 a.m., the next time you do it at noon, and then 9 a.m., then that's not going to make a lot of sense. But as long as you're consistent and just making that one observation per day, it's actually quite helpful.
Okay, thank you.
Yep. And we do know that snowfall will compact, and it will, if you get a bunch of snow in the morning and then it starts to rain and the snow will melt, we know that we're not going to get the greatest amount of snow. So there's actually some of those videos on the training on how to measure snow. It talks about trying to get the snow when it's at its peak before it starts to compact and melt. So there is some more training available when it comes to snow measurements. It gets really tricky when it's snowfall.
Is there any instruction as to where you should put this rain gauge? I mean, obviously,
yep.
If I put it, most of my weather where I am on Green Bluff is coming from the south. So if I put a rain gauge on the north side, it's going to be somewhat sheltered from my house, by my house rather. So there's some instruction on that.
There is. That's one of the great things about CocoRa's is they've invested in some training videos, and that's one of the ones that's included is where to put your rain gauge. What's the ideal location on your property? Because everybody's situation is going to be different. People have trees and big canopies, and some people have fences or like the north facing wall. So trying to find the ideal spot where you're away from all the other obstructions, trees, houses, and fences, but you can still access it, because obviously if you can't get to it every day, then you're not going to send the measurement. So there is a video that really walks you through trying to find that ideal location on your property.
Good, thank you.
Yep. And I'm looking at that website again, CocoRa's, and one of the little links on there, it says training animations. And I haven't seen that latest one. I've seen some videos that they did probably 10 years ago, but now they've actually made little cartoon animations about how to make your measurements and probably how to cite your rain gauge and everything else. So lots of great resources on that webpage. Oh, I can't hear you.
Can you share the animation?
Sure. Let me look at it. I'll share my whole screen real fast. Should be able to see it right now. So these are all on YouTube, it looks like. Water equivalent, freezing rain. I'm looking for, take a tour of the weather of the interactive map. Thought there would be one on here about, oh, here's getting started. The basics of measuring. So yeah. Just some neat little videos.
I noticed they're all very short as well, so that's
yes, exactly.
Thing. Yeah.
Yep.
For the guys who have lower
short attention spans. Very busy. Gotta go. I can only handle 2 minutes at a time.